Hey kiddos, today we are going to be talking about solving systems using elimination. So at this point we have two methods for solving systems. The first method is graphing, the second method is substitution. Now each of these methods is like a different tool, right? You have to pick the right tool for the job. If you're trying to build something and you needed to put a nail into something, you wouldn't use a screwdriver to do that. You could absolutely use a screwdriver to hammer in a nail, but it would be much easier to use a hammer, right? If you're putting on makeup, you wouldn't want to use the wrong brush. Let's say like you're trying to do your brows. You could do your brows with a kabuki brush, but that would be really, really difficult to get that kind of precision using the wrong brush. So using the right tool is super, super important. You want to make sure you pick the right tool to do the job. So there are certain situations where using elimination would be very, very useful. So we want to use elimination when one set of variables has the same coefficient and opposite signs. So for example, right here we can see that we have positive 5x and negative 5x. Now if we were to combine these equations together by adding down, the 5x and the negative 5x would cancel out. That's exactly what we want. They would eliminate each other, and that's why this method is called elimination. Essentially what that does is it allows us to then go and solve for y. We're going to take that y value and then plug it back into one of the original equations so that we can solve for x later. Okay, so I have a couple examples on how to use elimination, but the process of using elimination is super difficult to kind of explain. So here are the steps listed. Again, these steps are in your notes. They're the notes I've already posted on the daily agenda. Instead of going over this process and talking you through it, instead we're just going to talk our way through it as we do the examples, because that is probably the easiest and most streamlined method of learning elimination. Okay, let's look at example 1. So we are looking for the same variable with opposite sign coefficients, right? So if you look at the y's, we have positive 3y and negative 3y. So looking right here, I can tell that if I were to use elimination by combining terms going down, that those would eliminate out. So let's do that. I have 4x and 2x. If I combine those, I would get 6x, not 6x squared, just 6x, combining the coefficients, the numbers in front. 4 plus 2 is 6. The 3 and the negative 3 cancel, so I don't have to write anything for y. When I combine going down, 16 and 8 make 24. Now, this is going to leave me with a really simple one-step equation. I can solve for x by just dividing both sides by 6. Okay, so when I do that, I have x now isolated equaling 24 divided by 6 is going to give us 4. Okay, so I have 1/2 of the ordered pair solved for, so x is 4. Now, with elimination, in order to solve for the other variable, I'm going to take that value, x equals 4, and I can plug it in to either the top or the bottom equation. It does not matter when I plug it into. So because it doesn't matter, I usually just go for the top equation. It's right there on top. No particular reason why I'm doing that. I'm just picking that one because it's there. So I'm going to go through it and I'm going to rewrite, switching colors, rewrite this equation. So I'm going to keep the 4. Instead of x, I'm going to put in a parentheses. Okay, plus 3y equals 16. Now the reason I put that parentheses in is because I'm going to be entering in a value, x equals 4. So in that parentheses, I'm going to write 4. Okay. And now I can simplify. 4 times 4 gives us 16 plus 3y equals 16. And this is a two-step equation. I'm going to subtract 16 from both sides. Oh, that got away from me. Okay. Subtract 16 from both sides. That cancels out. And 3y is equal to 0, which a lot of students tend to think they made a mistake when they get 0, but 0 is a number. So even when I divide 0 by 3, I still get 0. And so that is my value for y. Y equals 0. And so my ordered pair is 4, 0. Okay, that would be my point of intersection. That would be the solution to the system. So again, the process for this is fairly easy and super streamlined. You are going to look for the variable that has the same coefficient, 1 plus, 1 minus. That's an indication that you're going to use elimination. Then you combine going down, so you just add the numbers together or subtract. And then you solve for one of the variables. You take that, you plug it into one of the original equations, and you solve for the other variable. Okay, let's go ahead and look at one more example. Okay, here's another example of elimination. We know that we're using elimination here because the 6x and negative 6x, right, are going to eliminate out. So again, I'm going to combine going down, negative 6x and 6x eliminate out, 5y and 4y make positive 9y. 1 take away 10 is going to give us negative 9 because 10 is bigger. And then I'm going to divide both sides by 9. So y equals negative 9 divided by positive 9 is negative 1. And that is our value for y. So I can go ahead and enter that into the answer for the ordered pair, negative 1. Again, I take that value, that y equals negative 1, and I plug it into either of the equations. So I can use top or bottom. I'm just going to plug it into the top just to be consistent. Okay, so I have negative 6x plus 5. Again, instead of y, I'm putting in negative 1 equals 1. Okay, let's simplify. Negative 6x. 5 times negative 1 is negative 5. And that equals 1. Now we're going to work backwards. This is a two-step equation, so I'm going to add 5 to both sides. Okay. Continuing to try to solve for x. 1 plus 5 is 6. And then I have one more step. I'm going to divide by the number in front of x. I'm going to divide by negative 6. Divide by negative 6. And when I do that, x equals 6 divided by negative 6 is negative 1. So our x value turns out to be negative 1 as well. And so the point of intersection, the solution to the system, is negative 1, negative 1. Okay, so again, I look for the value that's going to eliminate. I solve for the variable that's still there. I take that and I plug it back into one of the original equations. And that will give me my point of intersection. Okay, we have one more example. Okay. Now, looking at this, you can see that the y's are going to eliminate. I have positive 10y and negative 10y. So again, when I add down, I'm combining 2x and 2x makes 4x. The y's are going to eliminate out, so now I have to write that down. 16 take away 4. When I combine those, that gives me 12. Then I divide both sides by 4. That gives me x equals 12 divided by 4 is 3. Okay. And now that I know x equals 3, I can go ahead and plug that into the equations. Again, doesn't matter which one. I'll stay consistent and use the top equation. So I have 2 times 3 plus 10y equals 16. Simplify this. 2 times 3 is 6 plus 10y equals 16. I'm going to subtract 6 from both sides. Again, this is a two-step equation. So I'm going to start away from my variable. 10y equals 10. And my final step, I want y to be isolated, so I'm going to divide by the number in front, divide by 10, divide by 10. And once I do that, I get y equals 1. And so my final answer is 3 comma positive 1. And so that would be the point of intersection, the solution to the system. Okay, so at this point you have 3 methods for solving systems. You have graphing, which you want to use when I provide a graph or when you have both equations that are easily graphable, like y equals mx plus b. Then you have solving by substitution, which you want to use when one of the equations is more difficult to graph. You don't want to use the intercepts and you don't want to convert to y equals mx plus b. That's when you would use substitution. And then you have elimination, which is specifically used when you